Yes. A very good morning to all of you. So my name is Piyush. So I will be your trainer for this course, and we will be starting with our new course, that is SD-WAN. Cisco, or we can call it Viptela SD-WAN, right? So we will be covering few topics. Let me just walk you through. First will be introduction to SD-WAN. Under introduction to SD-WAN, we will discuss why we need SD-WAN, what is SD-WAN, and after that, how it operates. Right. After that, we will come on to key features of SD-WAN, and we will discuss what are the different features that are available in SD-WAN. Right. So some of the features are application quality of experience, interconnecting multiple clouds, direct internet access, APIs. These all are the features related to SD-WAN. After that, we will go to SD-WAN control plane, and we will understand how SD-WAN control plane operates. SD-WAN control plane consists of underlay overlay routing, OMP, overlay management protocol, right? All that stuff. Then we will move on to SD-WAN data plane, and we will discuss what is a T-lock, what are colors, what are carriers, what are the different data plane encryptions available, VPN segmentation, all that stuff we will discuss. After that, we will move on to, okay, let me write it side by side. SD-WAN data plane. After that, we will move on to SD-WAN deployment. Deployment means we will discuss how you will do the onboarding of the devices, what is whitelisting, what is identity, what is T-lock extension. We will discuss stuff like that, right? And then we will discuss SD-WAN management plane, right? SD-WAN management plane will consist of the policies, SD-WAN templates. So all these things we will do practically, right? After this, I will be building a lab for you, and I will be showing you how to run that lab, right? And apart from this, we will also discuss something called centralized data policies, and apart from this, application aware routing, right? So before going too much deep into this particular topic, right, I want all of you to understand what do you mean by the term SD-WAN and why do we need it, right? So anyone of you have joined the demo session? Anyone? Okay, Dharmendra. Dharmendra has joined the demo session also. Hi, Aure. Okay, that's good. So, what I am hoping here is, what I am hoping here is not everyone has joined the demo session. So let me just give you the demo once again. In the demo session, we have discussed why do we need SD-WAN, right? But let me just walk you through again. So guys, before going to SD-WAN, what is WAN? WAN stands for wide area networks, right? What do you mean by wide area network? Wide area network means whenever we are connecting to networks which are physically separated by some distance, or you can say are existing on different location, right? So when I'm saying they are separated by some distance or on a different location, what do you mean by that? Let's say this is my office 1 and this is my office 2. This office is in, let's say, India, and this office is in, let's say, US, right? So these two offices are separated by some distance, a lot of distance, right? And are on different locations also. Like you can see, one is in India, other one is in US. Wide area network means I want to connect these two offices, right? I want to connect these two offices. So guys, what is the first option available to us? So I call those options as transports. Transport means whatever service I will choose here, that service will be responsible for carrying my traffic from office 1 to office 2. I will call my service as transport. You can call it transport or you can call it service, right? So I don't want to dig too much into different service types that we have that we have in networking, right? Or that we have in service providers. But let me tell you some services. Like we have MPLS, right? We have internet, right? We have 3G or 4G, or we also call it LT, right? After that, we also have something called lease lines, right? So these are the different services available to us, or you can say these are the different transports available to us. Guys, now just tell me honestly, how many of you understand what is MPLS? Okay, that's fine. Have you ever seen MPLS deployed in real-time scenario? Okay. So guys, Arindam, can you go on mute? Yeah. Now, if you ask me what is this MPLS, let me tell you one thing. MPLS is a private cloud. What it is a private cloud that is used to connect that is used to connect two locations together, right? That is used to connect two locations together, right? So if you ask me, Piyush, what is MPLS? So I would say it like this. Let's say this is your office 1, right? And this is your office 2. Right? And you want to connect these two offices. So what you can do? At both of the offices, you can buy a MPLS link at this office also and at this office also, right? From whom? From the service provider, right? And now what you can do is you can run any routing protocol. Now this is the most important part. Listen to me carefully. This is the device of service provider and this is here the device of service provider. What we will do, we will run a routing protocol with the service provider and we will pass on our networks to whom? To the service provider from office 1 and from office 2. Now service provider will exchange those routes over this cloud. We don't have to understand how things are working in this cloud, right? So somehow, if I assume, let's say this is my A network in office 1 and we have a B network in office 2. So what will happen at the end? Office 2 devices will have information about A network, and Office 1 devices will have information about B network. Right? So, what this MPLS service is doing to me, with the help of this service, Office 1 A network is able to communicate with Office 2 B network and vice versa. So what is MPLS? MPLS is a private cloud that is used to connect two different sites together. I hope everyone is clear with this, right? After that, we also have one more type of service that we call internet. Right? What is internet? Now let's say in the same example, you people have two offices, office A, office B, right, at location A and B. Office 1, office 2, right, networks are A and B. Now they are connected to whom? To internet. So just assume it like this is internet, right? Now if you ask me, Piyush, will this A network can communicate with this B network over internet? No. Why? This is a private network. This is also a private network. And this is a public network. Right? This is a public network. Two private networks cannot directly communicate over a public network, right? Cannot directly communicate over a public network. But how it was possible in this case? Because what kind of service we were using? MPLS. And what is MPLS? MPLS is a private cloud, right? That is used to provide us what type of service? That is used to provide us service in such a way that if two offices are separated by some physical distance and both have the MPLS connectivity, they can communicate with each other. How? The edge devices on the office side will be forming a neighborship with the service provider devices and advertising all their routes. And service provider will be responsible for advertising routes from one office to another office. But that thing is not true for the case number 2. In case number 2, two private networks cannot by default communicate over a public network. So what we usually do in these cases? We usually build a IPsec site-to-site VPN. We usually build a IPsec site-to-site VPN. Now just be with me, you will be understanding everything. Let's divide this term. Now what do you mean by the term VPN? VPN means virtual private network. Right? Virtual private network. What do you mean by the term VPN? VPN means connecting two private networks over a public network. So that is what we are doing. We are connecting two private networks over a public network. So this particular term is itself defining it, right? That we are trying to connect two private networks over a public network. Now what do you mean by IPsec? IPsec is a protocol suite. What is IPsec? IPsec is a protocol suite. What it is providing us? Security. In terms of security, what IPsec is providing us? It is providing us confidentiality, data integrity, authentication, and at last anti-replay. Now maybe these terms are new to you or you are not familiar with these terms, but we will be discussing it in future. What is confidentiality, what is data integrity, what is authentication, what is anti-replay. But what you have to understand here, that the IPsec keyword is here defining what security? That whatever information these two private networks will exchange will be secured. Right? So IPsec is responsible for providing the security. And what do you mean by site to site? Site to site means we are connecting two sites together. We are connecting how many sites? Two sites. Right? Any problem in understanding this? Now you can write your yes or no in the chat. I can see, so that I can see and I can continue. Any sort of doubt you people have, you can ask. Feel free to ask. No problem. I'm here to help you. Thanks Atul for the feedback. Now let's move to the next point. Some people ask this question that Piyush, these are only two sites and you are connecting them with IPsec site to site VPN, and we understand that. What will happen if we have multiple sites? So Cisco has a solution, right? So let me just make a new diagram. So let's say this is your site 1, site 2, site 3, site 4, site 5, right? We have multiple sites and all the sites are connecting via internet. Praveen, I will answer your question, just 2 minutes. Site A, 2, 3, 4, 5. 5 sites are there. They want to communicate. The first option is we can build a site-to-site VPN between site A, site 1, site 2, site 2, site 3, site 3, site 4, site 1, site 3, site 1, site 4, site 1, site 5, like this. Otherwise, what I can do is I can configure here a solution. I call it DMVPN. DMVPN stands for Dynamic Multi-Point VPN. Now, what do you mean by VPN? All of you know VPN means connecting to private networks over a public network, right? Second, what do you mean by multi-point? Multi-point means from site A, I will create a VPN. With the help of that VPN, I can connect to site 2 also, site 3 also, and site 4 also. I can connect to everyone. So this is what we call multi-point. On site 2 also, with the help of one VPN, it can communicate with site A also, site 3 also, site 4 also, and site 5 also, right? So this is not a point-to-point VPN or not a site-to-site VPN, right? This is a multi-point VPN, that with the help of one VPN, we can reach multiple destinations. But if you check case number 1, in case number 1, we can just communicate with one party because it was site to site, right? So we have both options available while deploying VPNs. We have point to point also, we call it site to site, and we have multi-point also, we call it DMVPN, right? So if you have 2 offices or more than 2 offices, we can connect them together, right? With the help of MPLS, or you can connect them with the help of VPNs, right? Now Praveen is saying, can we communicate ISP link or MPLS with each other? Keep this thing in mind that ISP and MPLS are 2 different type of services. You cannot intermix between them. You cannot intermix between them, right? Now my question is pretty simple. How traditional networks looks like. So guys, if you people are working in real-time scenarios, you will be understanding what I'm trying to explain here, right? how traditional networks looks like. So every organization, right, have these things. First is data center, second is headquarters, third one is branch sites, or some people also call it remote sites, right? Now every organization in this world will have a data center, a headquarter, a branch site, and a remote or a remote sites. Yes, Randhi, DMVPN is a solution which is only available on Cisco devices because this is a solution provided by Cisco. Right. Now, every organization will have a data center, headquarter, and a remote site. So, how an organization will look like? Let me give you a WAN perspective of it, right? A WAN perspective. So, let's say this is your data center. Guys, understand it very carefully because these are the building blocks for SD-WAN, right? I'm not saying that you will not be able to do SD-WAN practicals if you don't understand this. No. If you have to clear the picture in your mind, what is SD-WAN, why we require it, these things are very important. Now, let's say guys, this is your data center. Right. So in data center, I'm just talking about the WAN perspective and what is data center. So data center is a place where we kept all our servers, right? All your virtual machines are installed on those servers, all your applications, all your database, everything is there in the data center, right? Now understand it like this. Let's say you have a remote site, right? This is remote site or your headquarter, whatever you want to think it. Let's say this is the headquarter. Now these headquarter sites want to communicate with my data center. Yes. So I want to connect them. Now data center will have both types of connectivity. When I'm saying both such types of connectivity, what do you mean by that? It will have internet also and it will have MPLS also. So data center will always have both sort of connectivity, MPLS also and internet also, right? Now let's say there is some headquarter site which want to connect to my data center. So I will provide him a MPLS link, right? Now what will happen? This headquarter site can communicate with my data center with the help of this MPLS, right? And it can access all the services with the help of MPLS. Any doubt in this? No, we are good. So what does the traffic flow? Traffic flow is from my HQ or from my branch site. Traffic will go to MPLS cloud, right? And from MPLS cloud, it will go to my data center. Now, what about the inter-network traffic? Okay, there are two types of traffic: intra-network, which belongs to same organization, and second is internet. Internet means the traffic which want to go out of my organization, right? When I'm saying it want to go out of my organization, what do you mean by that? That traffic can belong to Google, it can belong to Yahoo, it can belong to YouTube, LinkedIn, Facebook, right? And any other thing which is existing on internet, right? Any government website, right? So how we are sending the traffic from my headquarter site to branch office, to MPLS cloud, to my data center. Now this is about the traffic which belongs to intra-network. What about internet traffic? Internet traffic will be forwarded like this: from my headquarter, branch site, to MPLS cloud, then to my data center, and from my data center to internet, right? So let me just put it like this. So all these things are existing here. So if I have to tell you about the flow number 2 from headquarter side to the data center, from data center to the internet. Now the first question is, why we are not sending traffic directly to the internet from the headquarter site? Headquarter site has this sort of link, MPLS, and from MPLS cloud you cannot send traffic directly to internet, right? Now second question is, Piyush, what we can do is we can purchase an internet link here also, like this, for this office, and we can send it directly to the internet. But I have a question. This is a rule. Before sending traffic to internet, right, what we have to do is we have to pass it through few security devices, right, like from a firewall, right, second from a IPS, right, third, any other thing coming in your mind, guys? Right, so pardon, cost, okay, I will come on that point. So before sending it to the internet, we have to pass it through few security devices like firewall, IPS. Now you are like, Piyush, why? See guys, if I want an internet connection here and I want to send traffic directly to internet, I have to put a firewall on this site, right? So first thing is, okay, let me write it here. First thing is install firewall on the site. Second, manage it. So you require a security engineer also to manage it, right? Third thing, if this internet goes down, still you require the same set of policies on your data center firewall, right? Right. So this particular thing is called distributed security. What we call it? Distributed security. What do you mean by distributed security? Distributed security means we have remote sites. Every remote site have its own firewall and we have a set of policies defined there, right? But nowadays companies are not nowadays, I'm talking about 10 years back. 10 years back companies were moving from this distributed approach to a centralized approach. Why? The reason is simple. First of all, they want to save the cost. They don't want a firewall here. First thing. So they don't have to install a firewall on site. So if there is no firewall, there is no management, right? Second, what they will do if they have an internet link also, right? If they have an internet link also. You can ask me a question, Piyush, what will happen if this MPLS goes down? What will be the backup? Yes, we can have an internet link and we can build a VPN from this site to my data center, right? So VPN will act as a backup. Right? And what is the centralized approach? That whenever any site want to reach internet, instead of sending traffic to my data center, instead of sending traffic directly to internet, let me send it to my data center, right? So guys, if I have to represent this particular thing to you, it should be like this. Can you see here? So this is any of my remote site. This is my data center. Now this is WAN. WAN means it can be any WAN, it can be MPLS, it can be internet. In all the cases, traffic is going from my remote site to the data center, then to the internet. Now you will ask me, Piyush, what are all these applications? These are Dropbox, Drives, Google Drives, right? Microsoft Word, Microsoft Excel, right? PowerPoint, Google Plus, and SAP application. So all traffic is backhauling to my data center, right? And what is the advantage here of having this design? The advantage is centralized security will be there, right? We will be able to save the cost. Why we will be able to save the cost? Because we don't need firewalls on all the sites. We just require firewalls on my data center from where we are exiting and entering all the internet based traffic, right? So this sort of design we were using in my WAN, right? Nowadays also more than 50% companies are using this design. More than 50% companies. And what is happening because of this? Let me tell you an example of this. Because I work as a network consultant, right? So I come across multiple problems that we have with this design, right? What are that problems? Let's say, guys, let's say this is North America, and this is your South America. Right. So let's say you have a data center here in North America, fine, and you have a remote site here in South America, and they are connected. They can be connected by MPLS or they can be connected by VPN, right? But what is the design saying? The design is saying that whenever we want to reach internet, we have to go to the data center. So let's say this is your data center, and this is your remote site, right? Now whenever any traffic want to go to internet, it will go to the data center. Let's say the users who are sitting in South America remote site want to access a government website. Which website? Government website, right? But traffic can directly flow from this site to the government website server. But how it will flow? It will flow to my data center, and from my data center it will come back to the government website, right? So this is called, guys, inefficient routing. We are adding a lot of latency to the traffic. You will say, Piyush, how we are adding a lot of latency? We are adding a lot of latency. You are sending a traffic from one continent to another continent and back hauling it back to the government website, right? Sending it back to the government website. So what we are doing, we are adding latency to the traffic because of our design. And guys, think about this thing. If you are in India, let's say we are in APAC or we are in Asia, you can think of this as Asia. And let's say I have a company here, right? And its data center is in US. Now try to understand, if you want to open any website, let's say you want to do net banking from your office, right? So how traffic is flowing from your company network to your data center and back to India? Are you able to understand this approach? So what we are doing, we are adding latency to the traffic. That is not correct, right? So guys, let's discuss about inefficiencies of traditional WAN. What are the different inefficiencies of traditional WAN? First one is cost. Why cost? Now, from where we are sending all the traffic on internet? From my data center, right? Am I audible to all of you, or it is for all of you or only for Rajesh? Okay, give me a minute. My internet connection is fine. I don't have a problem here. If it breaks again, let me know, right? Okay, if it breaks again, let me know, no problem. Okay, so the first point is cost. What do you mean by cost? So increased bandwidth demands are forcing companies to upgrade their private WAN, and which is very expensive. What do you mean by that? Let's say guys, you have a remote site, right? Today you have a 20 MB MPLS link. You have a 20 MB MPLS link, right? Let's say now the business is growing, your site is growing, so you want it to be 60 MB. So it is too expensive. Why it is too expensive, guys? MPLS services 3 times if we compare it to normal internet, right? So first problem is cost. First of all, on the data center side, we have to buy bandwidth for all the sites because all the sites are sending traffic back to my data center. First thing. Second thing, on the sites also, if the demand will increase, I have to increase the capacity of the MPLS circuits, right? Second point is higher latency. I just explained you with the help of 2 examples. So let's say you have some websites which are local to the country, but the countries have to send traffic back to my data center and the traffic will come back to the government websites, right? Third point, availability. Why I am calling it availability? Let's say your company has a single data center, right? And that data center is in US, right? And let's say there is some natural calamity in US. So my whole organization is dependent on that data center for sending out traffic to the internet. Fine. So I call it single point of failure. So if someone asks me, Piyush, you have to design a network, I will never design that network and make it dependent on one data center, right? Last point is velocity. What do you mean by velocity? Now guys, let me tell you one thing to explain this point, velocity. Sorry. Now, let's say you want an internet connection. Right. So what do you do? Send a request to service provider and they will come to your place and provide you the connection. Right. Because internet is so demanding nowadays that internet provisioning is everywhere. But the same is not true for MPLS, right? So let's say you want a MPLS connection. So sometime what will happen in the area where you require it does not have a provision. Now, if they have a provision, they have limited bandwidth. Right? So, deploying MPLS process is a bit slow. I'm not saying in all the cases, but yes, in some of the cases, the process is slow. Guys, I can assure you this thing that velocity is also one of the reasons why I am saying this, because in the past what I have seen that when I was working for one of the company, so that company has one of the site in one of the location, and what happened that due to the increased business demand applications, we have to increase the bandwidth of the MPLS circuit of that site. But what service provider told us that there is no provision. We had a 40 Mbps circuit there, and in that area only 40 Mbps can be allocated to my organization. right? So there was no provisioning to increase the bandwidth. And service provider told me that they will take 6 months to have a new line there so that they can provide me 100 MB bandwidth. So that's why I'm saying deploying MPLS is a bit slow, right? Now guys, these are the four inefficiencies of the traditional WAN. One is cost, second is latency, third one is single point of failure, fourth one is velocity. What we require now? We require some solution that can help us. We require a solution that can help us run this WAN efficiently, right? So guys, this particular solution will be my SD-WAN. So SD-WAN is designed to address these challenges, right? So how things will look like once SD-WAN will be in picture. Let's say this is your company, this is your remote site. So the remote sites will be reaching to the internet directly. Can you see? So there is no latency. Right? There is no latency. Second, no extra cost on DC side for bandwidth, right? No dependency on data center for internet based traffic, right? And no dependency on MPLS links. Now you will ask me, Piyush, why? Let's say this is a remote site, so this does not require a MPLS to reach the data center. So this can be connected to my data center with the help of internet link also, with the help of a VPN, right? So if there is no MPLS provisioning available, what I can do, I can purchase the internet link, I can send traffic directly to the internet, and second thing, with the help of that internet link, we can build a VPN with my data centers, right? So this is how things gonna be fine. So SD-WAN is basically here to address the issues that we have discussed. Now you can ask me one thing, that Piyush, how we come across these lot of issues at the same time. See, the point here is we people are moving to cloud. Let me give you a very small example. So what was happening in the past? Let's say I work in a company and let's say I have some data. So data was local on my laptop, or that was on the server which are located in my data center. So let me give you a pictorial view of it. Let's say these are your remote sites, right? So all people are working on these remote sites and this is your data center. Fine. So in data center we will have some servers. So all these people are working, right? Their data is stored on these servers which are in my data center, right? Here. So maximum traffic in the past, maximum traffic for an organization was intranet, right? But if I talk about today, it is not the case. So let's say this is your data center. You have some servers, right? This is your internet, right? And these are your cloud applications. right? Anything, it can be anything, right? And these are your remote sites. So these remote sites are accessing the applications which are on cloud, which are directly on the internet, not in my data center, right? So guys, the need is changed. Earlier, the remote sites want to reach the data center, so the network was designed in that way. But now all the applications are present on the internet. So network needs to be changed, right? A transformation is required. So that's why we are bringing in what? We are bringing in SD-WAN. Because now the application that the users are accessing, 90% of the applications are on Google. They are internet based. They are not intranet based, right? So earlier we were sending all the traffic to my data center because maximum all the applications were hosted in my data center. But now this is not the case, right? That's why we require a new solution, and that solution is called SD-WAN. So SD-WAN is there to remove the inefficiencies that we have with our traditional networks, right? Next thing, next thing, any other problem we see with traditional WAN? Yes, guys, now your turn. Any other problem you see with traditional WAN? A minute, guys. Right. So that point is decentralized network management. I explained this particular term. Yeah, applications will be running slow. It will be there will be latency, right? So decentralized network management means that in traditional WAN we are managing all the network devices manually. Guys, think of your WAN, right? If you are working in an organization, you are managing all your VPN routers or your MPLS routers manually one by one, right? That should not be the case with this traditional WAN, sorry, with SD-WAN, right? So in traditional WAN, what we are doing is we are managing all the components of a network. In SD-WAN, we will be managing all the components of the network. From where? From a centralized point, right? What we call that centralized point? We call that centralized point my vManage, right? I will tell you in future. Clear? So in case of traditional network, so if I have to differentiate it, in case of traditional network, traditional network means we need to configure each and every device individually. Second, in case of SD-WAN, this will be centralized. Every device will be managed from vManage. Every device. So all your configuration, right, whitelisting, policies, templates, security, everything will be done from my vManage, right? So so this is one of the main benefit, one more main benefit of using SD-WAN, that there will be a centralized management of all the devices. There is no individual management, right? Fine. So guys, if you have any questions, you can ask now. I'm here to answer it. Right. So many times people ask me, if someone asks me why SD-WAN, right? So you can answer him like this. If you can explain him the inefficiencies that we have for the traditional WAN networks, first thing. Second thing, you can tell him that in case of SD-WAN, we are going to manage and operate large enterprise networks, enterprise WAN networks. Now, many people have this question in mind that Piyush, if we deploy SD-WAN or if we use SD-WAN, are we removing MPLS? No, 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 it is not like this. Fine. You will understand how SD-WAN will work, right? So SD-WAN is just a new way of deploying WAN. I'm not saying connecting WAN, right? I'm saying deploying WAN. When I'm saying deploying WAN, how your WAN traffic will go from one side to another, that we have to see how it is different in SD-WAN, right? So that we will discuss. So SD-WAN is used to manage and operate large enterprise WAN networks, right? What is the first benefit? The first benefit is single management plane. What do you mean by that? If you talk about traditional networks, how you are managing them, you are managing each and every device individually. That is not with the case of SD-WAN. In SD-WAN, all the components of the networks are managed centrally, right? And we call it a single management plane, right? After that, there are few more benefits that we will discuss time to time, right? So keep this thing in mind. There are two types of SD-WAN solution Cisco is selling nowadays. First one is Meraki. Second one is Viptela. We will be focusing only on Viptela solution, not on Meraki solution, right? First thing. Second thing, Meraki is there for the small enterprises and Viptela is there for the large enterprises. Right. So just let me give you an overview of it also, if you want to remember it. Can you see here? Cisco Viptela enterprise level SD-WAN solution supporting complex WAN topologies with a higher degree of customization. Cisco Meraki SD-WAN solution with a basic level of customization designed for small and medium sized organizations. Right? Any problem in understanding this, guys? If you have any question, you can ask. Okay. So I hope so we are good. Yeah, please, please. When you are saying multiple links, what do you mean by that? Okay. Okay. So my friend, in both the cases, in traditional also and in the case of SD-WAN also, we are managing it in the same way, right? So if you have seen in the organization where you work that on the MPLS link you have a BGP neighborship, right? And on the internet based link you have default routes, right? In case of SD-WAN also configuration everything will remain same, but how two sites gonna communicate, that will be the crux or change here, right? How two sides gonna communicate, that will be the crux and change here. So I hope you are clear with this. Any problem you can let me know, right? So I will not take much of your time. Let me just go back. Just a minute, guys. I want to bring one PPT to you. So guys, we will start discussing about different components of SD-WAN, but let me just give you a last summary of what we have discussed, right? So traditional WANs, so how they were designed. So just stay with me. They are designed to route traffic from remote sites to company data center using MPLS or using internet. Second, nowadays business needs are changing. Why they are changing? Because we are moving applications to clouds. Right? So what we have done is we have moved the application from a data center to public clouds. Like I gave you multiple examples. So to work very efficiently in these particular cases, what we want to move the user traffic from branches to the cloud directly, not backhauling it to the data center, right? Are you clear with this point? I hope so you are clear, right? So because of this rapid digital transformation of enterprise, it creates a new requirement for security, cloud and internet connectivity, WAN management and application performance. So that's why we require SD-WAN. Right. Now, why it is called software defined WAN? Right. So first of all, let's come to software defined aspect of it. Then we will move to the WAN aspect. Right. So guys, I think you have heard this term. First of all, you have heard this term SDN, software defined networks. Right? What do you mean by software defined networks? Right? Software defining network means separating control plane and data plane. Separating control plane and data plane. Right? Separating control plane and data plane. Now, what do you mean by separating control plane and data plane? Guys, again, this is a debatable topic. So, what do you mean by SDN? SDN means separating this approach. So let me try to make you understand what people think. People think it in a different way, and I don't think so. They have studied it properly. So what example people give? Let's say it is a router, and now router is doing all the forwarding for you. When I'm saying router is doing all the forwarding for you, so how router will do the forwarding? With the help of routing table, right? Or with the help of CEF table if I have to be accurate, right? And how this routing table is built? With the help of control plane. Now let me give you a small example. What do you mean by SDN? So if I talk about control plane means, let's say you have these 7 routers. They are connected like this, right? Right? They are connected like this. Fine. Now my concern is very simple. R1, R2, R3, R4, R5, R6. Try to understand the traditional way how they are communicating. So every router will have a control plane. How? Let's say you are using OSPF as the process. So every router will participate in OSPF, right? Right? Every router will participate in OSPF. Now, first of all, they will form neighborship. Then they will form adjacency. After forming adjacency, they will run SPF on database to find the best path. And then they will form the routing table. Right? And on the basis of that routing table, they will do all the forwarding. I think everyone is clear with this thing. Yes, we are clear because we know the basic concepts. Now guys, my second question is, or my second concern here is, what we have seen here, all the devices are running their own control plane process and are responsible for forwarding data, right? So this is called a distributed approach. What we call it? Distributed approach, right? So we are able to connect the things that in case of traditional networks, we are using a distributed approach. What is happening in a distributed approach? That every device is running its own control plane process. Every device. That control plane process means any protocol that is required to exchange the routing information. It can be EIG, RP, it can be OSPF, it can be BGP. After exchanging the information, they will be able to find the best route and they will be defining their routing table. Now guys, tell me one thing. If you want this router to have a different best path, what you will do? You will log in into this router and you will change the cost. If you want on this router, again you will do the same thing. Again you will do the same thing. Again you are able to understand that this is a distributed approach. Why I am calling it a distributed approach? Because if we have to make the changes, we have to make the changes on each and every device individually. But what is SDN? SDN means separating control plane and data plane. So what people think that we are totally removing control plane from the devices. No. So separating control plane and data plane means, let's say you have a controller here. What you have? Controller. And the same sort of design you have, let's say these are 5 routers this time, right? Instead of 7. Right, we have 5 routers like this. So SDN means these devices will communicate with this controller. Let me change the color to make it more clear. These devices will communicate with this controller. They will run a control plane process, but with whom? With the controller. They still have a control plane with controller, right? With whom? Again I am saying with controller. Now all the routing decisions are taken by controller, and all your devices are only responsible for forwarding the data plane. It is not like this that we have removed control plane from the devices. No. We have not removed any control plane. Control planes will still be there, but devices will not exchange any control plane information among themselves. No. Devices will be exchanging control plane information with whom? With the controller. And after that, they will know, let's say here you have X network, here you have Y network, here you have Z network. So this R1, R2, R3, let's say R1, now R1 will get to know from the controller that to reach Y network I have to go to R2. R2 will get to know from controller to reach X network R2 has to go to R1. R3 will get to know this thing from controller that to reach X and Y network it has to go to R1 and R2 respectively. Right? So these particular devices are not running any protocols with each other. They are running everything with the controller. We call this a centralized approach. What we call this? We call this a centralized approach. Right? So guys, we people are moving routing from a distributed approach to a centralized approach, and this is all about SDN. According to SDN, we are moving from a distributed approach to a centralized approach, and we are separating control plane and data plane. We are not totally removing control plane from the device, but we are changing the way control plane works in traditional networks. Is this part clear to you? If you have any question, I am giving you some time, you can ask. Okay, I think we are good then. Nice. So let me show you one more picture. So this picture is explaining, this is your Viptela cloud, right? Viptela cloud can be on-prem. What do you mean by on-prem? On-prem means controllers of Viptela deployment can exist on-prem. On-prem means in your premises. In your premises means in your organization, right? In your organization. So Viptela components can be on-prem. On-prem means in your organization, and mostly organization will have these components set up in their data center. Now you ask me, Piyush, do we have on-prem deployment for any of the customer? No, I have not seen till now. So every company is going with which deployment? Cloud deployment. Second type of deployment is cloud. Cloud means setting up all components on Cisco or service provider cloud from where you are taking the service, right? So they will not be deploying any of the Viptela controllers in your premises, right? They will be deploying it on the cloud. Now you will ask me, Piyush, if everything is on cloud, how my sites will communicate? So I will give you an idea of it, right? So SD-WAN will provide you routing, will provide you analysis, segmentation, security, everything. So all the services are there. Deployment can be, there can be any deployment, there can be any service you will get, right? With the help of any transport and any location, whether it is your data center, your campus network, with your industrial site, small office, home office, or your cloud site. All the sites will be able to communicate with each other, right? Now the question is, if all the things are setting up on the cloud, how these sites will communicate. So guys, there is a component of SD-WAN. We call it V-Edge, Viptela Edge devices. So V-Edge devices are always installed on-prem. On-prem means these are like your WAN routers. These are like your WAN routers, which will which are physically existing in your enterprise and forwarding the traffic, right? But the management expect there are some more components of controllers of Viptela like vSmart, vManage, vBond. All these management aspects will exist in where? Will exist in the cloud, right? Or if the deployment is on-prem, they will be existing in your data center, right? So there are basically 4 components that we are going to discuss that will be part of Viptela deployment. First one is vSmart, vManage, vBond. These 3 are the management aspects, right? And they will be existing where? They will be existing either in case of on-prem deployment in your premises and in case of cloud deployment in the cloud. There is only one component that will exist on the site, that is called vEdge. vEdge is very similar to your WAN router, right? And it is responsible for forwarding all the traffic. If you have a question, you can ask now. Are we good, guys? Fine. Let's start with the next thing. Now we are discussing about SD-WAN components, right? Now what are the different SD-WAN components, right? So guys, SD-WAN is segregated into 4 planes. First one is the orchestration plane. Second one is your management plane. Third one is the control plane. And the fourth one is the data plane, right? And each plane has its own function and responsibilities, right? And each plane is independent of each other, right? So let us compare it with the traditional network. Let's compare it, right? So what do you mean by data plane? Data plane means the actual data, right? What do you mean by control plane? Control plane means your protocols. Remember OSPF, BGP, EIGRP, right? If you are running multicast, PIM, all these protocols, right? And what do you mean by management plane? Management plane means how you are accessing the device. So you were accessing it with the help of telnet or SSH, and we were doing everything on CLI, right? So this is what you understand from traditional networks. Fine. So data plane means the actual data that we are sending across from one site to another site or from one user to another user. Control plane are the different protocols, right? And management plane means how we are going to access the devices. But in case of SD-WAN, we have one more plane that is called orchestration plane. So we are going to discuss it in the upcoming time. What do you mean by orchestration plane? So orchestration basically means automation, right? And what we are automating here, we are automating onboarding of devices. I will explain it to you in the future, right? Onboarding of devices, or how we are going to add, you can say, a new member into the SD-WAN component list, right, into the SD-WAN controller list, how we are going to do that. So I'm just giving you a small, you can say, a picture to understand these things. Right. So guys, this will be your cloud, right? In this cloud, your vManage will exist, right? Your vBond will exist, and your vSmart will exist. You can see these different signs. So this sign is to represent vManage, vBond, and vSmart. So vManage is there to provide you the management plane functionality. vSmart is there to provide you the control plane functionality. vBond is there to provide you orchestration plane functionality, or you can understand it like onboarding of devices. Right? And these all devices, vManage, vBond, vSmart, can exist on-prem or in the cloud. Right? So it will depend on your deployment. Now, what are these types of devices? These are your vEdge routers, right? So these will exist on your sites. And I explained you these particular devices will be very similar to your WAN devices or your WAN routers. And they are responsible for carrying the data, right? So you can see all 4 SD-WAN components. We have management plane also, we have orchestration plane, we have control plane, we have data plane. We have everything in picture, right? So management plane, orchestration plane, and control plane will reside inside here on your cloud or on your premises, whereas all your sites, right? All your site means all your data center branch sites or your cloud-based sites will have the vEdge installed, right? So let me just open this lab to show you a picture. So guys, this will be our topology of doing the practicals. So how I have set it up, let me show you. Right, look here. Can you see this particular part of the network? This is my cloud, right? Where I have hosted a vManage, a vBond, and a vSmart, right? This is my data center where I have 2 vEdges, and other 3 are my remote sites. 2 of the remote sites have both the type of connectivity, MPLS and internet, but one of the remote site only have MPLS connectivity, right? So again, I am telling you, this is my cloud. You can see my cursor where I have all my controller setup, right? vManage, vBond, vSmart, right? Apart from this, I have 2 remote sites which have both the sort of connectivity, MPLS and internet. I have 1 remote site which only have MPLS connectivity, no internet is there. And at last, I have a data center which have 2 vEdges, right? And a firewall also for sending traffic to the internet, right? So if I tell you about the traditional design, it is like this from this remote site, traffic will go to the data center, and from data center it will go to the internet, right? So this is how connectivity will be there, and we will be focusing on this lab in future. Now let's understand every component one by one. What is vManage? So like I told you, vManage is responsible for the management plane of the SD-WAN fabric, WAN, right? So it runs a user interface of the system. and your network admin. So your network engineer has to log in into this device if you want any configuration, addition of anything, modification to the SD-WAN fabric, right? This particular vManage will also show you analysis. We call it analytics, right? Analytics means the graphs and reports for all the devices, right? Apart from that, basically you can say it is a tool which is used by admin to create the policies, templates, configuration, any sort of thing. If someone has to do, he has to use the vManage, right? So basically you can understand it like this. What it is the GUI aspect of the fabric, right? After vManage we have vBond. What is vBond? Let me tell you this it in a very simple words. Guys, vBond is the, you can say, authentication hub of SD-WAN fabric. Now guys, you have noticed one thing that simultaneously I have started using the term fabric. Now what is fabric? I will be explaining you, right? Don't panic first of all. Second thing, what do you mean by authentication? Authentication means, who are you? Prove me. So, like I told you in this particular diagram, that these are the controllers. Whether it is vManage, vBond or vSmart, all these are the controllers. So what is vManage? vManage is there to have the GUI aspect of the fabric. All the policies, templates, configuration, analytics, troubleshooting, everything will be done through vManage, right? Now, what is vBond? Like I told you, vBond is the authentication hub. What do you mean by that? Let's say guys, this is a new VH. This new VH want to join the fabric. What do you mean by joining the fabric? Joining the fabric means to be part of the fabric, right? So we call this process as onboarding. Onboarding. Whenever you people join a new company, you have to go through online, virtual or in-house onboarding for that company. In the similar way, when you have to add any device to the SD-WAN fabric, right, we have to onboard that device. It's not like that any device can be part of SD-WAN fabric. No guys, again I'm repeating, no. Whenever a device will come to get onboarded into the fabric, that device has to go to vBond and authenticate itself, right? So any new device which is going to be onboarded needs to be authenticated from vBond, right? This thing is clear. So all the authentication, that who will be part of my SD-WAN fabric and who will not be a part of my SD-WAN fabric, who will be deciding this thing? This thing will be decided by vBond, and how he will decide, that we will check in future. So vBond is managing the orchestration plane, or you can say is acting as authentication hub. Any new device that is getting onboarded needs to be authenticated from vBond, right? So I will discuss other things in detail. Fine. Third controller that we have is that will exist in the cloud or in on-prem is vSmart. What is vSmart? vSmart is used to manage the control plane information. It means vManage is there to perform the routing functions. Right. What do you mean by routing functions? This is basically the brain of the fabric. Fine. All your routing policies, security will be advertised from this vSmart. Fine. So I can give you an example. So let's say this is your vSmart. Just concentrate here. This is your vSmart. These are your vSmarts, right? So all your V edges will be forming a peering with whom? With vSmart, right? And vSmart will be distributing the routing information. Along with routing information, they will do a lot more work, right? They will do a lot more work like IPsec key distribution. We will discuss it in future. Let's not get confused now, right? So they will basically act as, I think if you know, then only compare RR in BGP, route reflectors in BGP, right? So all your non-RR devices, right, will form a peering with the RR in BGP, and all the routing information will be exchanged via the RR. In a similar way, we have the vSmarts in case of the SD-WAN deployment, where all your WAN edges, V edges, will be going to form a peering with your vSmarts, and vSmart will be distributing that information further. Let's say this is your device A, this is your network A, and here you have a network B. So this network A is advertised from VH to whom? To the vSmart, and vSmart will advertise it to B, right? So this is only the control plane aspect. Now if you ask me, Piyush, how the traffic will flow? Traffic will flow directly, right? So vSmarts will never participate in the data plane. They will never be in the path of packet forwarding, right? They will never be in the path of packet forwarding. They are just providing the control plane information to all the VH devices, which they are getting from the VH devices, right? So if I have to explain it, it is like this: one VH, vSmart, VH, two vSmart, right? It will advertise network information to vSmart. vSmart will further advertise it to the other VH, right? So this is here to exchange the routing information, right? This thing is clear? Fine. Now if I talk about V edges, what are V edges? V edges are basically the data plane component of, or you can say V edges handle the data plane component of the SD-WAN fabric. So these are actually your WAN routers, which will be installed on the sites. Which sites? It can be your data center, it can be your HQO sites, it can be your branch sites. On all the type of sites, which type of devices are installed? Your V edges, right? This thing is clear? Now guys, I am trying to give you an overview of how things are going to work in case of SD-WAN. So first of all, you don't have to think too much about it, right? So first of all, let me just give you a small overview how. So let's say this is your vSmart. right? This is your WAN edge 1, this is your WAN edge 2. This is your WAN edge 2, right? Here we have a network A, here we have a network B, right? So what we understood? We understood is that this particular WAN edge will advertise A network to V Smart, right? Which network? A network. So we call it control plane, right? We call it control plane. Clear? Now this V Smart will give the information about this A network to WAN edge 2, right? This is again control plane. In the same way, WAN edge 2 will advertise network B to V Smart, and V Smart will give it to WAN edge 1, right? Which network? B, right? So WAN edge 1 will have information about which network? B network. So WAN edge 1 knows to reach B network, I have to go to whom? I have to go to WAN edge 2. And WAN edge 2 also know to reach A network, I have to go to whom? WAN edge 1, right? So what is this? This is control plane. Now let's talk about how these two networks will communicate. Let's say now A want to reach to B. Now they will communicate directly. Right? It's not like that actual traffic will also pass through vSmart. No, vSmart is only handling the control plane aspect. So this is your data plane traffic. Right? This is your data plane traffic. So data plane traffic will flow directly from one WAN edge to another WAN edge. Right? Now guys, let's see a real picture of it. How we will see a real picture of it? Now let's have a diagram. Let's say this is your site 1, right? This is one of the user in site 1. This is your site 2. Right, this is one of the user in site 2. This is internet. Which transport I am choosing? Internet. Right? So this is your vSmart. Clear guys? This is your VH1, right? This is your VH2. This is your vSmart, right? So this is a public network, all of us know. So let's say this LAN is 10.110/24 and IP address of the user is 10.1.1.1. This is 21.10/24 and IP address of the user is 21.1.1, right? Now understand it very carefully. So these particular sites will have the public IPs. Let's say this public IP is 200.1.1.1. This site will have a public IP 201.1.1. This site will also have 202.1.1.1. Right? Now what I am trying to say, this VH1 will be exchanging the routes with the vSmart. So they will use a protocol to exchange that routes. We call it OMP. Overlay Management Protocol, right? What we call it? OMP. OMP is very similar to BGP. We will discuss OMP in detail. You don't have to worry about OMP right now. Clear? Again, I am saying you don't have to worry about the OMP right now. So we will discuss about OMP in detail, right? So you just have to remember OMP is a protocol which we run between VH and vSmart. We actually don't run it, it is automatic, right? So with the help of OMP protocol, VH1 will share the route to vSmart and vSmart will give it to VH2. Here also OMP, right? And in the same way, VH2 will give the route to vSmart and vSmart will give it to VH1 with the help of OMP. Now let's say 10.1.1.1 want to communicate with 21.1.1. So 10.1.1.1 will send the traffic. destination IP will be 2111, right? So guys, this particular physical network is called underlay network. Right? Underlay network, or let me tell you an easy word, physical network. Right? Underlay network or physical network. Now what is going to happen is, as soon as this VH1 will have information about 20's network, it will form a tunnel from VH1 to VH2. Right? It will form a tunnel from VH1 to VH2. Right? It will be IPsec tunnel, and I will call it a overlay network. Right? Now, might be you are confused what is underlay, what is overlay. Underlay means my physical network. Overlay means the network which I am building over that network. Right? So, do you remember about GRE? So GRE is a type of overlay. Right. So what is going to happen now? As soon as this user will send the traffic, it will be received by VH1. Now VH1 will encapsulate this traffic and secure this traffic with the help of IPsec, right? Secure means it will encrypt it. Let me just encrypt it with the help of this red box, right? And after that it will add a new IP header to the traffic. In this new IP header, there will be a new source IP that will be 201.1.1 and destination IP 202.1.1.1. Right? Now, this traffic will be forwarded from this overlay tunnel to the internet and from internet to the VH2 device. Right? So this is your actual traffic. It is secured plus it is encapsulated. Right? And it is traveling directly to the other side, not via vSmart. Right? So what we call it overlay tunnel. So all your data plane traffic, again I am repeating, all your data plane traffic will be going directly from one VH to another VH. So this is your data plane. Which plane? Data plane. And earlier the update exchange that was going through your vSmart were your control plane, right? So I hope you are clear with the control plane and the data plane. Right? So always keep this thing in mind that VH devices are of two types, right? They can be virtual appliances also and they can be physical appliances also. We will deal with physical appliances in this course, right? And how you will onboard a physical device, physical VH into a SD-WAN fabric, I will be telling you that thing in future. We call it ZTP. Some people also call it PNP, right? We will be discussing about these terms. And like I told you, what is OMP? We are going to discuss that. So don't worry about it, right? So guys, if you have any question, you can ask now. Okay guys, these are old messages. So you have to send me on the chat if we are good. So we will move on. Okay, it's fine. So again, I told you, you have to give it some time. You have to revise the videos. You will be clear with it. It's not rocket science. It's very easy. I find it pretty easy, right? Now let's move on to the slides one by one. Now, so can you see here? There is a slide representing vManage. So this is the sign of vManage, right? So all your centralized management, your configuration, monitoring, everything is done with the help of vManage. vManage can be a ESXi based device also, right? Or you can manage it with the help of vCenter. So let me make it a simple for you. So you will get the image of vManage from Cisco. You can install it on the ESXi server, right? Or you can install it on the cloud, right? And what is the use of vManage? It is used for centralized management. Clear? Next, we have vSmart, right? So vSmart deployment is also same. So these are virtual devices, right? These are always deployed on ESXi, right? Second thing, what is the use of vSmart? For exchanging the routing information, for traffic engineering. Traffic engineering means for path manipulation, for policies, for VPN policies. What do you mean by VPN policy? So VPN is the term used in case of SD-WAN fabric, and it is very similar to VRF. We will discuss it in future. Wait for some time. Service chaining is also a concept that we used in SD-WAN, right? So let's not dig too much into these terms right now. We will discuss about them in future. Encryption key propagation. I told you that vSmart is also used to exchange the IPsec keys, right? After that we have vBond. So it is used to bring up the secure. It is used to provide us the secure bring up process, right? So any appliance which needs to be added to the SD-WAN fabric needs to be a part of your, needs to authenticate itself to vBond, right? And in the end, we have the VH devices, Viptela, right? So this is how a Viptela VH devices looks like, right? So this is the hardware specializations we have for a VH1000 series hardware, right? So this is the Viptela 1000 series device. It is 1 rack units. There are 8 1G ports, right? We have a separate management port, a console port, USB port, some LEDs they are there, SD card slot is there, and one new thing is there that you have to read about, and I will be discussing these things tomorrow. What we call them? Yes, all these appliances are always virtual, right? So what you can do is you can bought a Cisco C or U series server, right? And you can deploy on those servers, right? Now read about TPM chips. What are TPM chips? I want you all of you to read about them, right? So every VH device will have a TPM chip, right? So what is the use of this TPM chip? You should be knowing about it. So this is how a VH2000 device looks like. So it is a bit bigger than the VH1000. So this is how a VH100 looks like, right? So the difference is only in the capacity, and no else difference is there, no other difference in the working. And this is how a 100M device looks like. So every device will have one thing that we call a TPM chip, right? Now guys, look this particular picture. So let's start from the bottom. All your sites will have what sort of devices? VH, right? So they are the devices which are responsible for the data plane. Let's say any traffic want to go from home office to the data center. So they will be forwarded by the VH on the home office sites to the data center via these transports. What are these transports? It can be internet, it can be MPLS, right? After that we have these controllers, right? What are the controllers? We have vManage, vSmart, vBond. What do you mean by vManage? vManage is used to provide us the GUI of the fabric for all the SD-WAN components that we have over there. What is vSmart? vSmart is there to provide us what? The routing functions, right? V bond is there to provide us authentication, right? So this sort of lab you can build on your own if you want to build, right? So you can see the simple lab, but we will be using our own lab, right? So we will not start it like this, right? So before starting with the actual topic, I want to explain you what do you mean by overlay network and underlay network. So guys, just look here, right? So let's say this is your physical network. These are 4 routers connected with a cloud. So guys, don't get confused with this cloud. So this cloud is also a router, nothing else, right? This is R1, this is R2, this is R3, this is R4, right? Now what do you want? You want okay, someone has a question. Someone watching. vBond, vSmart, vManage, everything is virtual. You have to install it on your ESXi server. And second thing I told you, they can be deployed on the cloud also. And 99% of the cases, this is the case. People are deploying it on the cloud, right? Now guys, try to understand what do you mean by the overlay network and the underlay network, right? Underlay network means my physical network. So let's say this is 201.1, this is 202.1, this is 203.1, this is 204.1. Now if you are not clear, my IP is actually 201.1.1. I am omitting these ones, right? I am not mentioning these ones here, so I am simply writing the IPs, right? So this is my physical network or my underlay network. And as for this router R5, all these networks are directly connected. Every router will be able to reach the other side. So on R1, define a default route, define a default route, define a default route on all the routers. So what will happen is all these underlay IPs will be reachable. Right? So the first thing that we require is we require to build the underlay reachability. So if I talk about this lab also, let's say, let me go to the lab. Okay. More actions, start all nodes. Fine. So if I talk about this lab also, right? So let's say this is VH3. Fine. So if I want to bring in VH3 to the fabric, so first, what is the requirement? VH3 should be able to reach all the controllers. So that is the underlay reachability I am talking about. It means the IP address which is present on the WAN side of VH3 should be able to reach the IP addresses of vManage, vBond, vSmart, all these devices, right? So this is called underlay connectivity. Now what do you mean by overlay connectivity, right? What do you mean by underlay and what do you mean by overlay? Right. Now let's say you are clear with underlay. Underlay means the physical network that we have, right? So overlay means the network which I am building over this network, right? So just assume it like this, that these are your sales users, right? And what you want for sales users, you want this sort of connectivity. what sort of connectivity you want. Just look here, this is for the sales. Fine. You want R2 should send all the traffic to R1 and R1 will forward it to R3. It means this topology is called hub and spoke. Right. You want for sales traffic. For sales traffic, if R2 want to communicate with R3, R2 will go via R1. Right. What we call it, hub and spoke. Let's say this is hub and these are your spokes. Right. So this is my overlay network that I am building over this underlay network, right? And what I want is this particular traffic from this particular sales server to this particular sales server should travel via R1, right? Okay, this is one type of overlay network I want to build. Second type of overlay network, let's say guys, these are your marketing servers. You want to connect them in a full mesh. Full mesh means whenever this server want to communicate with this server, they can go direct. So let me build one more diagram. Fine, this is for which servers? This is for marketing servers. And what we want here? We want this overlay network to behave like this, that when R2 send traffic from this sales server to this sales server, right? Sorry, from this marketing server to this marketing server, it will go direct. It will not go via R1. So you can see we have one physical network, but over one underlay network, I have built different overlay networks. I am correcting myself. I just speak that wrong. Over one underlay network, I am managing two different overlay networks. Right? Over one underlay, we have two different overlays. Underlay means how they are connected, how they are physically connected. Overlay means how we want them to communicate, how we want them to communicate. Clear, guys? Fine. Right. So I can connect all these routers depending upon what service I am connecting from one site to another site in a different way, right? So for a sales, I can have a different topology. For marketing, I can have a different topology. For HR, I can have a different topology, right? Clear? So we are forming different overlay networks. Now, if you are clear with this, I hope you will be awesome, right? You should be awesome with my point number 2. Now let me write. What is underlay network? Let me write it. What is underlay? Underlay network is there to build the IP reachability, right? IP reachability. So let me show you a small underlay network example. So in this example, I have 4 VHs, right? So you can see VH1, VH2, VH3, VH4, right? So this is the underlay or the physical network that we have between these VHs, right? Now, what do you mean by the overlay network? So by default, what is the rule? By default, one VH will try to build a logical tunnel. Logical tunnel, let's represent it with T and let's call it what? Overlay tunnel. Right? With all available VHs. So in this case, it will be with this also, with this also, and with this also. Right? So VH2 is going to communicate with all the VHs directly. Direct. Right? So this is your which network? Overlay network. Right? Any problem? That's good. Right. So guys, I think we are clear with what do you mean by underlay and what do you mean by overlay. Clear. So now let's start with the next topic that we have in the plate. What I call it? I call it VPN 0. Just give me a minute. Okay. So guys, this is our lab, right? So if I come here, this lab, so guys, what I have done is, all of you have seen, I have configured the ports which are connected to my controllers in a particular VLAN, and you also have to keep this thing in mind while doing the practical, that the VLAN configuration on the switches is sometimes not saved, right? Right, so we have done that. Let me just discuss about nice. So topic for the day is, I should say new topic for the day is a very important topic, SD-WAN VPNs. Right. So first of all, VPN is nothing but a VRF. Right. Virtual routing and forwarding instance. Clear? So in case of SD-WAN, we are actually using the keyword VPN instead of VRF. Fine. So the first sort of VPN that we will see in SD-WAN is VPN 0. VPN 0 is basically called transport VPN. Right? What we call it? Transport VPN. What do you mean by transport VPN? mm, the interfaces which are going to connect to the WAN devices are configured to be member of this VPN. So whether you have MPLS connectivity or you have internet connectivity or you have 4G or LTE connectivity, any type of WAN service you have to connect those interfaces to my WAN edge device, and you have to configure those interfaces to be a part of which VPN? Transport VPN. Transport VPN is used to build the underlay connectivity. Right? So VPN 0 number is reserved for which VPN? Transport VPN. Right? Second, we have VPN 12511 and 5132655535. We call them service side VPN. All interfaces which are going to connect to LAN side are configured to be member of this VPN. Right? Next, VPN 512. This is called management VPN. Right? So this VPN is there to provide out of band management to your SD-WAN fabric. Right? So I have shown you on your vManage, your vBond, your vSmart, and on your vEdges, we have a separate management port that can be used for out of band management. Right? So VPN 512 is the management for the management aspect. Right? If you want to manage their devices, manage their devices means taking the GUI, CLI, whatever you want to take, right? So these are the two most important VPNs. First one is transport VPN and second one is the service side VPN, right? So every interface that is connected to the WAN devices will be part of the transport VPN, and all the interfaces that are going to connect to the LAN side are called service side VPNs. Let's see a picture to better understand it. Now guys, just be with me. I am responsible here to make you understand everything. So this is your WAN edge device, right? So we have which interface? G 0 by 0, 0 by 1. These are connected to my WAN devices. Let's say G 0 by 0 is connected to internet, 0 by 1 is connected to the MPLS, right? So these interfaces will be member of which VPN? VPN 0. Clear? Second, what is the use of VPN 0? To communicate with the controllers. Which controllers? vManage, vBond, vSmart, right? After that, what is the use? To communicate with other vEdges. So all this communication is going to take place from VPN 0, right? Now second, what is management VPN? So management VPN is there to provide the out of band management, right? So I am not explaining this here, right? So maybe in future we will discuss, but this is not an important aspect. Second is service side VPN. So let's say you also have two more interfaces, 0 by 2 and 0 by 3. So you configure 0 by 2 to be member of VPN 5, 0 by 3 to be member of VPN 10. On VPN 5 you are running, only have a directly connected network. On VPN 10 you are running dynamic routing, right? So all the interfaces which are going to connect to the LAN side will be part of the service side VPN, or we call them service VPNs, right? Now how this thing will work in a real picture? Now look here, very interesting point guys, and this is the last you can say last topic that we are going to discuss for the day. I will not make it difficult for you. Now try to understand my point. Just a minute. How this thing will look in a bigger picture. Very interesting guys. Now you will be able to understand what I was speaking from a very long time. Let's say this is your VH1, this is your VH2. These are two different sites, right? I'm not here talking about any control plane. We are only focusing here on the data plane. Look here. So I have an interface connected to my public network or to a WAN edge device. This interface is going to be member of which VPN 0, right? This interface is going to be member of which VPN 0. Now the LAN interfaces, let's say this is interface 1, interface 2, interface 3. So all these three interfaces are member of different VPNs. So how many service VPNs we have? 3. 5. Service VPN 5, 10 and 33. On the other end also 5, 10 and 33. Now let's say 5 want to communicate with 5. So 5 will send the traffic. Traffic will be passed from the WAN network to the other VH. From VPN 10 to VPN 10, VPN 33 to VPN 33. So same service VPNs will communicate with each other by default, right? So if you ask me, Piyush, whether VPN 5 will communicate with VPN 10, no. What do you mean by VPN? VPN means VRF. VRF means we are virtually dividing the routing table of router, right? So if we are dividing the routing table, why I want them to communicate? But I'm not saying it is not possible. If you want to do it, you can do it by changing the by default behavior, right? But by default, different VPNs will not communicate. So now you have an idea. What is that idea? That if I have multiple VHs, they are connected by a WAN, they are connected by some WAN, they can communicate with each other. First thing, that the WAN side will always be part of VPN 0. The LAN side should be part of any service VPN, VPN 1 to 511 from 513 to 65535. If you want to make that communication by default, they should be member of same service VPN, right? If they are member of different service VPN, they will not communicate. Now the point here is how this VH2 will get to know that whether the traffic belongs to VPN 5, VPN 10 or VPN 33. So guys, all the traffic will be tagged with this VPN number. With VPN number to provide the segmentation. Segmentation means VH2 will get to know that this particular traffic belongs to this particular VPN. Right guys? Any problem you can ask. Okay, let me clear this picture more. Let's bring it here. Look guys, now this picture is making the things more clear. This is one WAN edge, second WAN edge, third WAN edge. All are connected to internet. So this is my WAN, right? So all these WAN networks are member of which VPN? VPN 0, right? Clear? So over VPN 0, they will be reaching the controller. It means all the routing information will be exchanged from the controller. Routing information, right? From the controller. Once the routing information is exchanged, now my LAN sites, means service VPNs, will be able to communicate with each other. Now see here, I told you these traffic will be encapsulated by whom? By IPsec. In IPsec, ESP performs in IPsec, ESP performs the encryption and authentication functions. So guys, you can see, let's say this is your data that you are trying to send. So you can see a VPN tag. So VPN tag is there. Now you will say, Piyush, here it is 5 or 10. Guys, this is the size. VPN tag will be of 4 bytes, right? And VPN tag will consist of a numeric value which will define this traffic belongs to which VPN, right? So guys, this particular thing is called VPN segmentation, right? Any particular doubt in this? Guys, feel free to ask, because I will have last 30 minutes for your questions only. Right? So we have different VPNs, VPN 5, VPN 10, same VPNs will communicate with each other, right? Yes, yes, please. Service side VPN simply means on your VH devices, wherever you will connect your LAN interface, right? That particular interface will be part of some service VPN, right? So all your LAN side will be part of service VPN. Now guys, you know what is the beauty of this SD-WAN solution? Now look here. Let's say this is your WAN VH1, this is your VH2, right? And I already told you the WAN interfaces will be member of which VPN? VPN 0, right? Now here you have VPN 1 also. So what is VPN 1? VPN 1 will be the service side VPN. This is also VPN 1, VPN 1 will be the service side VPN, right? By default, what we know, different VRFs will not communicate, but here it is not the case. So this is the beauty of SD-WAN, that all the traffic that is coming from VPN 1 will automatically enter into VPN 0 and pass to the other VH. And similar cases with the reply. And this all process will be automatic. You don't have to do anything, right? So all the service VPNs which will exist here, service VPN means my LAN side VPNs, which are existing here on the VH device, will be communicating with the other service side VPNs, but the same service side VPNs, 1 with 1, 2 with 2, 3 with 3, 4 with 4, right? And all the traffic is passed through which VPN? VPN 0. Clear? So someone was asking about what is service VPN. Service VPN just means the LAN side of the SD-WAN fabric. Okay, let's say you want to connect them one by one like this. No, all these three interfaces can be member of same service VPN, right? Right. Now, let's say you want VPN segmentation. You want the network behind this switch can only communicate with the remote network that is behind some switch. So you can create a separate VPN for it. Let's say VPN 5, VPN 5, and this is VPN 10, right? So this particular VPN 10 will only communicate with whom? VPN 10, not with VPN 5, right? I can give you example like this also. Let's say you have these VHs These are your switches. I'm not using multiple switches, I will use multiple links, right? Now let's say this is network 1, 2, 3. This is network 4, 5, 6, right? And they are member of VPN A. I'm using, okay. Let me use these as VPN number 1, 2, 3. 1, 2, 3, right? 6. So that network 1 will communicate with 4, 2 will communicate with 5, 3 will communicate with 6. Are you clear with this? All of you? Guys, please answer. 1 with 4, 2 with 5, 3 with 6, right? Because they are member of same service VPNs, right? So the VPN which is present on the WAN side is called the transport VPN. The VPN which is present on the LAN side is called service VPN, right? So now you are clear about one thing. See, like I told you, this is a new way of doing the things. So it's not like that you will be able to digest it in the first go. It will take some time, right? So just try to picturize things in your mind. How you gonna picturize them? First of all, relax. Second thing, start thinking about it. What are the problems with traditional WAN? Okay, I'm good with the problems. Second, who is gonna address these problems? SD-WAN is gonna address these problems. Now, how? Okay, SD-WAN is going to do something. First thing it is gonna do, it is providing us the centralized management. How it is providing us the centralized management? With the help of vManage. After that, who will take care of the routing in SD-WAN? vSmart is taking care of routing. Third thing, who is taking care of authentication? vBond is taking care of authentication. What are vEdges? vEdges are the devices which are installed on all the physical locations, all the remote locations, data centers, headquarters that are going to pass the data plane traffic, right? What are the different SD-WAN components? We have orchestration plane, we have control plane, data plane, management plane. Orchestration plane is handled by vBond, management plane is handled by vManage, control plane is handled by vSmart, and data plane is handled by vEdges, right? Then just go through the working of each and every device like I told you. After that, try to make a picture, try to make a topology in your mind, how these different sites will be connecting, right? So you can see this is my cloud where all my controllers are hosted and all sites have vEdge installed. Now at the end of the day, my task is to make the communication possible between these vEdges, right? So these vEdges are going to communicate with the controllers also, but just for the control plane information, just for the authentication purpose, not for the data plane, right? So let's say I'm on R13. Let me go to R13. Show IP interface brief, right? And the IP is 10.3.13.13. 10.3.13.13 is IP of E0 by 0. That is very good. Show IP route. Okay. Here I have a loopback 10.1.0.16. Right. Now guys, what I'm going to do, don't think too much, right? What I'm showing you, just concentrate here. I'm tracing one of the IP address which is existing on switch 16, that is in my data center, from a remote site, right? And the SD-WAN is already configured and working here. Now I want to show you a very interesting thing. So traffic from iOS 13 device is going to 10.3.13.3. This is the IP address of vEdge GE0 by 2. That is the server side interface, right? After that, you can see IP 10.2.0.1. 10.2.0.1 is the IP address of, I think, vEdge2, right? vEdge2 service interface, service side interface, right? So what I'm trying to tell you, just a minute, let me bring my epic pen here. Fine. Just a minute, it will take like, oh, it is taking much more time. It is coming up, just a minute. So you have noticed that from a long time I'm using the word fabric, SD-WAN fabric, SD-WAN fabric. What do you mean by SD-WAN fabric? SD-WAN fabric means, think of, hey man, think of all these devices as a single device, right? VH1, 2, 3, these are physically different devices. But to explain you the meaning of fabric, try to understand it. This is my SD-WAN fabric, right? SD-WAN fabric means anything I am sending into this will exit out, and I will not be able to see what is in between. So I will not be able to see any IPs, any ISPs, anything, right? You can see from the trace, from R13 I am trying to reach a loopback on R16, right? So traffic is entering into R13, this is our VH3 IP, and this is VH2 IP, right? So traffic is coming here and going to Swiss 16, right? So this is what I'm trying to explain you here, that fabric means that we are connected to the same device. It will look like that both of the site, this is my DC also, and my remote site 3 also, both are connected to the same device, right? Clear? This is the meaning of the term fabric. I hope we are good, guys, right? So tomorrow we will discuss more onto this topic. I hope you will read about it, and if you have any questions you can ask. So tomorrow I will start with the onboarding process, right? Onboarding means I will tell you, I will discuss about the PKI stuff. I will tell you how you will bring up vManage, vBond, vSmart, all these things, right? So let me close these things. So if you have any question, feel free to ask. One thing I want from you is, this is my phone number, guys. Please create a WhatsApp group. So someone from you have to create, right? So who will take this responsibility?